Good afternoon. Welcome to Adventures in Elm. Elm is a programming language. It compiles to JavaScript and runs in the browser. It has a lot in common with the React framework in JavaScript, especially if you use React with Redux, because Redux was based on the Elm architecture. But Elm is a purely functional language. I'm Jessitron, or Jessica Kerr, better known as Jessitron, and I work at Stripe. At Stripe, I do Scala, Ruby, Go, Python, Bash. Sometimes I look at Node. Really, I do whatever needs done, whatever language the app I'm interested in is written in, because I like maintenance. I'm not a greenfield developer. That is not my preference. I want to take a program that's already useful and make it more useful and make it happy, make it stable. That's my passion. I'm also a backend developer. How many other people are primarily backend? Good. Okay. Me too. I'm a backend developer, and one of the reasons I like backend development is because I want to know my program works, and I want to be able to say how I know it works. And I tried it in my browser, and I clicked this button, and it did the thing. That does not count. So I don't like front-end dev, because it's really hard to say, how do you know this front-end works? And more importantly, after I change it, because that's what I want to do, I want to change it, I want to change someone else's code, how do I know it still works? How do I know it still works everywhere? So I like functional programming. But enter Richard Feldman. So Deech got married, and Richard and I sat during the whole wedding dinner, and Richard is a big fan of Elm. He uses Elm at no red ink. And he totally sold me on this, yes, we can actually have functional programming in the front end. And I was skeptical, because this is functional programming to me. Data in, data out, and the inside of that is perfectly predictable because it can't reach the outside. And this is UI programming to me. Everything's got to update everything else, and I'm really skeptical, and I have never liked it. So how does Elm make this pleasurable? Because that is the purpose of Elm. This is Evan Chaplitsky, and he is the creator of Elm. He is the product dictator of Elm, thankfully. Yeah. And he's super nice. He's just super nice. I mean, yeah, he wrote his master's thesis on like functional reactive programming or something, but he only cares about the bits of that are really useful. Evan is very pragmatic in the sense that he wants to make a language that makes people's lives better. Elm is a language of the Enlightenment. It aims for the greatest good for the greatest number, and not just in the present. Elm is about being kind to you as a developer now, by letting you write in a carefully typed functional style so you can get your program to run with no runtime errors. And it is also about you or your teammate in the future when you come back to it and you need to change something and you want to know that you didn't screw anything else up. And he wants it to be useful to the greatest number of existing people who are out there. There's a lot of JavaScript developers, there's a lot of people who know HTML and CSS, and that's his target audience. Or us, backend developers, who otherwise just can't frickin' stand doing anything in the front end. And he really trades off language features. He wants language features that make your life easier, but if they come with a whole ton of complicated consequences and make the code harder to get spun up on, then there's a balance there. I really appreciate that. Now I could go more into the philosophy of Elm, but I want to get to some code. So we're going to do hello world, and then we'll do hello world again, and then a very slight variation. Then I'll go more into the Elm architecture. I'll show you the demo app that I wrote in order to explore Elm and show it to you, and finally I'll preach some more. All right. Switching over to the terminal. If we want hello world in Elm, this is what it looks like. We open one file. Elm is made up of modules. Each module is in a file with the same name as the module, so this will be module hello. It can expose some methods to the outside. The module declaration is followed by import statements. I'm going to bring in graphics.element from Elm core. And I want to bring this element type in directly. The import statements are followed by however many functions you want to write. Each function has a name and a definition, and it may have a type declaration. So when I say main colon, I'm declaring the type of main, and main is going to return element. This is one of the 4 types in Elm that main is allowed to return because Elm knows how to put this on the screen. Then I can give it a definition, and the simplest Elm program of all is just show me this string. When I save it, I've got it set up so that Elm format kicks in. So here's a piece of the Elm language system that is kind to us because it refuses to let us argue over whether our code is formatted correctly. You just run Elm format and you live with it. And it's very carefully thought out. Somebody thought this out, so you don't have to. Go works the same way with Go format. But I think this is a great idea. Some things that Evan particularly values in Elm format are that things tend to be on their own line, even though that winds up making the code vertically taller, but it makes it better for version control. You don't often happen to change a line just because you really wanted to do something to the next line. I like Elm format. Okay, here's an Elm program. Let's hope the Wi-Fi works. I'm going to run Elm make on hello.elm. Elm make it's totally not make, it's just the compiler. It just compiles it into JavaScript. But first, okay, I guess it does do more than compile because it says, hey, I need some new packages. Elm has this pattern, and it's in the language architecture and it's in your code of gather some input, like I want to compile hello.elm, it can see hello.elm, make some decisions, like, ooh, I need Elm core, and then take action. And in this case, it pauses before it takes action and asks me politely if it may modify my file system. So yes, we do want Elm core, and now we have a couple things. We have Elm package.json, which is where the dependencies are declared. We have Elm stuff, which you should put in your git ignore, and that's where it downloads the packages to. And we have index.html, and that's the output. By default, Elm make compiles things directly into an index.html, so you've got a web page, poof, you can open it, you're running. In real life, I always ask it to output a JSON file or a JavaScript file instead, which I can then include in my own HTML, in which I can have additional JavaScript, I can have CSS and other links. Right, but we have the convenient index.html, and there it is. Hello, Philly. If we look at this, what Elm is actually producing, so I returned an element, which is some Elm type that it knows how to put on the screen. And what it has put on the screen, what is all this hooty hoop? I just want to see. This. Let me try that again. Inspect. Yeah, I don't know, it wants to put this on the screen. Here's our interesting bit though. Right here there's the div Elm put stuff in, and then it has decided that this element that I passed it shall be represented as a div with a bunch of characteristics and a span with a bunch of characteristics. Okay, whatever. This graphics.element package, it's in the core of Elm. It is what Elm is named after. And yet, it's unofficially kind of deprecated. The graphics.element package lets you define things that go on the screen, and you can say, put this above that, and put this to the left of that, and this to the right of that, which is exactly how I always wanted HTML to work. But HTML doesn't work that way. And it turns out that people who want to make HTML web pages don't want to learn a whole new way to represent things. They want to output HTML. So in the interest of being kind to people in general, Evan has sort of changed directions. And now the other type that you can output from main is an HTML. And then this can be a simple HTML.text. Great. Let's try building that. But I can't find module HTML because it's not in Elm core. So we need to install it. Here's another piece of the Elm language system, the package manager. I can say package install Evan, Elm HTML. Okay. Tricky things when you're starting to use Elm. The canonical thing for you to output is HTML, really, that's like the direction, and yet it's not in Elm core, it's in Evan's personal GitHub. This makes no sense. And Evan knows it makes no sense, he's just not in a rush he's got other priorities, whatever. He's the product dictator. We have to install from his personal GitHub. Now, it decides what it needs to do, and then it presents me with this and asks me if it may add this dependency to my dependency list. Of course, I'm good with that. Now, here's what's interesting. See the version range there? It's a big deal that it's a version range so that we can resolve dependencies, or transitive dependencies, across various libraries that we use, and be sure that everybody will work with everybody else, because we specified a range of version, not exactly one. And Elm package can confidently tell me that I should be able to use anything between 4.02 and 5.00 because Elm enforces semantic versioning. If Evan makes a bug fix, he can release that as 4.03. But if he adds an exposed method, adds something to his interface, he won't be allowed to release that as 4.03. It'll have to be 4.1 something. And if he changes any already exposed types or changes like the parameters or the name of a method that he already exposes that I might be depending on, he will not be allowed to publish that as 4.1. He will have to call it 5.0. So as long as Elm HTML is somewhere in this range, it is guaranteed to still work with my program. It's actually guaranteed to still compile with my code. And I mean, he could break it, but the interface will be compatible with what we have here. So I really like this. It's very explicit and it's very safe. And it is saving future me the headache of knowing whether I can upgrade my library. Because yes, as long as it's less than 5, I can. So yeah, go ahead and add that to Elm JSON. And then it's going to tell me that it's going to download Elm HTML and the transitive dependency virtual DOM. Now, one thing about transitive dependencies in Elm, I don't think there's anything I can call directly on virtual DOM, but in general, it's going to download the transitive dependencies because it needs them. It's going to put them in my Elm stuff, but my code will not be able to call directly through to a transitive dependency like virtual DOM unless I declare it as my dependency. So you never get sneaky transitive dependencies. Another nice explicit thing to help my future self. All right, once we've done that, we should have a new index.html. Nope, I did Elm package, but I have not yet done Elm make. I can tell because element is smaller. So let's build it again, and it works this time. There's our new index.html. And we have a different font. Ta-da! More importantly, if I inspect this, I still have this tiny little window, but there it is. The div contains exactly what I asked it to contain, which was some text. There's no hooty-hoo around it. Elm is just the mapping between this type HTML is not a string, it is a structural type, but the mapping from here to the HTML that I see in the browser is very clear. So like if I add a div around this, let's have a div with no attributes and just this child. Bam, thank you, Elm format. And then we build that again, and then we refresh the page. Now we have a div around it. So it's a very clean mapping. But you've got like type safety, which is awesome. Okay, but that's kind of boring. Now we have a static web page. We have this, a picture. But of course, we want our web page to change over time based on what the user is doing with it. So we need actually some sort of function from something that's going on in the outside world to our HTML. In the simplest sense, we can ask Elm for a piece of the outside world, and we can pipe that through a function in escape. Don't do this to me, Keynote. Nope, 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 not click, escape, escape. Okay, hard restart. Thank you, Keynote. No, really restart. Okay, meanwhile, I'll talk about Elm a little bit. It is in the ML family of languages. So you may have noticed like the colon for type declaration. And the syntax is familiar to people who write Haskell, but Elm is not Haskell, and it does not try to be Haskell. It is very pure, like Haskell mostly is, in the sense that you cannot have side effects and you cannot mutate anything. Every piece of Elm code is an expression. This is one of the ways that it like twists my head around and makes me think differently. I can't say, yeah, I know that. I can't say, hey, send this message over here and return this. There's none of that. There's no side effects. All I can do is return things, which is really restrictive and yet liberating in the sense that I know that nobody else's code is going to do anything weird. All right, I wanted iTerm, and my objective was to go to, oh, yeah, you can see this good. Let's read it, let's check out hello.elm again. Okay, I wanted to make this not just a flat HTML that's the same all the time. The whole point is that our program should be interesting. So we can change this to the third of the 4 types this can return, signal HTML. A signal of HTML is HTML for right now, and then it can change, and then it can change, and then it can change based on its input signals. So we need to import signal, and then we need a signal to start with, which can be, how about the mouse position? So my main can be mouse position, which happens to be a signal of a tuple of integers that are the x and y position of the mouse in pixels, I think. And I can pipe that to, let's make it a view function. I have to map over this signal because signal is a monad, approximately. And I can make a view function. So let's put this in a function. View will go from a tuple of integers to some HTML. The Elm as an ML has really good type inference, and I do not have to declare the type of my functions. That's totally optional. But I almost always do because it helps me get them right. So now view takes some parameters. I can do pattern matching in the argument list there to pull out the components of the tuple. And let's make it say something. Let's say x is equal to toString x, no automatic conversion from integers to strings, and y is toString y. Yep, help me out here, Elm format. There we go. Okay, so now we have a function, and we're starting with a signal and producing a signal of HTML that changes over time. And we can build that. Oh, except that we get a compiler error. Okay, I totally did this on purpose because this is my favorite compiler. So Evan, in his kindness, he has a whole repository in Elm Lang dedicated to please file issues on the compilers that confused you. Because if you get a compiler from Elm and you are confused, you're not stupid. We're not doing our jobs. Clear is determined at the ear of the listener, not at the mouth of the compiler. And Elm is kind this way. So I filed an issue, actually, a while back to say, okay, yes, I realize I'm using the wrong operator for string concatenation because plus is expecting a number and it is getting a string. The compilers are long, they've got colors, they just try really hard to be clear. And Evan was like, you know, that is a really common one. I'm gonna add a special case so that I don't stop having to look up how to do string concatenation. And he tells me that I need to use plus plus. Okay, I can plus plus. Nope, not there. And once we plus plus, that should compile. Yay, it does. And we can refresh our page. No, we don't have it open. Yay. All right, so now when I move the mouse, this changes. And if we inspect it, Here's our div, here's our string, and as I do stuff, the browser even very conveniently tells me it's changing. Now, my code, this is very important. My code is declarative. It says, I want the screen to look like this. Here is the HTML that it should look like. And then the Elm runtime, the virtual DOM bit, does the work of saying, well, right now it looks like this, and you want it to look like this, so I'm going to do the minimal updates. This happens in React as well. Elm has its own implementation. And no, I don't want to talk to my mother. No. All right. If one hard restart is the worst that goes wrong, we're okay. Yeah. So now Elm is updating the HTML as my signal of HTML changes based on the signal of the mouse position. We have to open Keynote. We have now implemented that last slide. Don't have corrupted. Okay. We've now achieved this, which is cool. We're now using the mouse pointer to make decisions about what the HTML should look like. So at this point, we want to say, well, that's really not enough. I actually want my HTML to depend on everything interesting that has happened, like everything the users clicked and what they've typed in, what the server had to say. And so I'm going to expand on this architecture in a moment, but we don't have time, unfortunately, to derive that in code, which is too bad because it's really fun. So we'll just do it in slides. This is functional programming, though. The Elm runtime is gathering data and taking the actions, and I get to make all the decisions. Elm says no to mutation and side effects, and it says no to null. And the result is you just don't get runtime exceptions from your Elm code. You don't get function blah is undefined on null. You don't get null does not have the property blah, which drives me freaking crazy. I had to write 8 lines of JavaScript for my demo app, and how many null pointer exceptions did I get? A lot. I'm really bad at JavaScript. But I did, well, okay, no, I did find a bug in the Elm compiler. I did get one runtime exception. But it was immediately. It was when I clicked. It was not like a weird corner case. Yeah, Elm also says no on the other side, on the Haskell side, to the generic monad. There's monads in Elm. List is a monad, signal, maybe, result might be. But they're just useful things. There is no generic monad type. There are no higher-kinded types. How many people like higher-kinded types? Okay, for one, we're still doing better than the majority of people. And so Evan says, you know, there's some value in that feature, but it's not worth the complication. It's not worth making people learn it. So in the opposite of Scala, Evan says, just no, we're not going to do that. There are no type classes. In Heather's talk yesterday, she talked about implicits and type classes and how it makes it a lot easier to compose a whole bunch of things. So specifically in serialization, you can put the type classes in one place, you can name them implicit and put them in the magic hat and let the compiler do the work of combining them. In Elm, we have to combine things by ourselves in code with our fingers. But not actually, not necessarily with our fingers, because we can do things like JSON to Elm. And you know, when the code gets to be a pain to write, whatever, then just have some code write it for you. And I'm typing random things. And here, this handy Elm app produces the Elm code that I need in order to process this JSON. So instead of the compiler doing the work, I can have this program do the work, and my code is completely explicit. Now I'm going to put this, I used this, and then I generated the code, and then I put it in my app, and then I totally changed it. To do, like, as I added stuff, I just changed the generated code. This is only a starting point, really. It's not like part of my build process or anything. But Elm says we value explicitness over not typing. And I've come to appreciate that. All right, so we've got no monads. We've also got no version 0 libraries. Publishing a package is a commitment. Semantic versioning will be enforced. You will have to upgrade versions if you change your API, like the first version. And yeah, you're not going to pull your package down and make it disappear or just change it out from under people either. So no 0x libraries, which is ironic because Elm itself is in 0.16. But that does make a statement, this language is not finished. So one of the things, we'll get to that in a sec, Elm is not done. It says yes to the virtual DOM, which lets us be very declarative. I'll figure out how to make the front end look like that. I can be fast at this. You just tell me what you want it to look like, and the more specific you are, the better. It says yes to compiler errors, which lets us have types. And I think this is really fun because last year at this conference, I spoke about types versus tests in Clojure and came down pretty solidly on the side of tests. But now I'm up here saying, I don't have time to write those tests. I haven't written any generative tests at Stripe in the last year. But the types are really handy here, specifically in the front end, where it's extra hard to test. And the types are keeping me from getting the runtime exception. And yes, I'm going to write some tests, but I don't have to write them in order to be sure that my code won't throw an undefined variable exception, like in JavaScript or Ruby. The types take me a long way, and I have found it pleasurable to develop with basically the compiler writing most of my tests for me. Elm says yes to boilerplate so that it can be really explicit, and also so that it can have a very consistent structure, which we'll see in a bit. And finally, Elm says yes to evolution so that it can be kind. This language is still changing. I don't recommend that you go write a whole bunch of production code in Elm because I want Elm to continue changing. I want Evan to continue refining this and making it better and better. He removes features. He's like, nobody uses this. Having it in the language is an additional complication, and it's an additional thing for people to have to learn. It's going away. I like that about it. Okay, back to the mouse pointer and make decisions. And I really wish I could do this in code, but we'll just add to the architecture on the picture. Here, I am depending on the state right now, but I really want to be able to depend on the state of everything that has happened ever that is of interest to my app. So I want to make decisions based on that. Of course, passing everything that has ever happened in every time would be like really big and really slow and really hard to think about. So let's simplify that. Let's just take one thing at a time, something that happened. And I need to output the HTML, but I can also output whatever it is I need to remember in order to make my next decision. That's called the model in Elm, and it gets passed back into my function along with the next thing that happened. So I can say, okay, based on this new thing that happened and everything that I remembered before, here's the next view, the next HTML, and here's the next thing that I need to remember. And so the model goes in a circle. Elm simplifies this a little bit, and it says, okay, we're just going to output the model, and we're going to use that. We're going to pass it through the view function to make the HTML, and also we're going to pass it back into, this winds up being called update, for the next iteration. That's it. This is the simple Elm app that if your Elm doesn't have any interactions with the server, this is the architecture. Now, there's a little bit more that goes on in like a practical one. For instance, in the view, I can set up like on-click events for the buttons and have that send me some specific sort of message back around. So that can loop around. Like I don't want to have to base whether you click the button on the mouse pointer and where your mouse was. Just look, when you click the button, send me this message. So you can do that. The other thing you can do is there's an additional output to update that lets you send messages to JavaScript. And that's where you can do things like hit the server or just put the focus in this stupid field. Why can't I do that in CSS? That was my 8 lines of JavaScript I had to write. And then the JavaScript can also send messages back to you through Elm. But those messages, both outgoing and incoming, those are data. And you can test that. It's kind of beautiful. All this part is handled in the Elm runtime. Okay, technically some of it is handled by Evan's Start App framework, and I do some of the wiring myself in my app just for entertainment, well, to explore the design space. Let's open my little demo app and I'll show you what Elm is sending through. It kind of, okay, open index. There it is. Okay, so what I wanted was an architecture diagram that I could annotate and zoom in and annotate deeper, which that doesn't work yet, but I can annotate this one. More importantly, I wrote my own little debugger as like built into the app. Elm has a generic debugger, but it doesn't work with anything that interrupts with JavaScript, so what good is it? I mean, you can use it if you just want to write like a game or something that the only input is user input in the app, but I made my own that's customized so you can see what's going on here. So if I move the mouse, doo-dee-doo, that moves. The clock here is an expression of this. The update function in Elm is an event loop. It gets one event at a time, and it updates its state with each event. And you can just add a quick little counter in there, and then you can document, like, when I click, it's going to tell me about it when I click, or when I press a key, it notices that. And there's the clock cycle that happened at. And the event loop with the clocks appears in a lot of places. You can look at actors as event loops in Erlang or in Akka. One thing at a time comes in, they take some action based on that, next message. This counter concept also exists in Bloom, which lets you do, program in like logic programming. It's a little logic language, but things change over time without mutating. It's pretty fascinating. Also, yeah, there's another paper at the end that references that. But this idea of an event loop of a single thread that's making one decision at a time is a structure that comes up over and over in programming. Game developers have been doing it for a decade or more. And I value that Elm forces me to think in that way. All right, there's the mouse, there's the keys, and I can put labels on here. This over here is the outside world. This represents everything in JavaScript. And I've divided my update into two parts because I like to say, okay, you clicked that. Does that mean anything for the business? So if I click, it doesn't actually mean anything, but if I hold down T and click, that means we should create a new text input and also send the outgoing message of please put the focus there. And then if I type something and hit enter, it recognizes receive text actually has to come back through the front end. Every time I type in there, there's like an on-input event that has to send me the message of what I just typed in there because you cannot examine the DOM. You do not have access to look at the DOM and say, hey, input field that I just created, what is in you? I've got to send that through every time and keep it in my model. Okay, so that is an implementation of this that like gives you some visibility into things that are coming in and going out. My code in there is pretty much to update the model and the view. And there's an interesting point about composition in Elm, because of course that was one of the first questions I asked, being a proper functional and OO developer, was how do you do components? Come back, there it is. So like this app has a couple components. There's the landscape over here, there's the messages pane over here, and the text input when it's open is its own component. And each of those is responding to messages and drawing itself. And the way you do that in Elm is with some boilerplate. So the update, model, and view methods are all made up of 4 pieces. So whenever I want to add a component, I need to add a call through in all of these places, which is kind of a pain, but turns out to be very explicit and a structure that I've found useful. This manifests in the file system like this. Each of my components has its own file with its piece of the model types and the update and the view. And then my main file puts those together. So it looks a little bit like, yeah, we're in landscape. Open main. go to the bottom. Yeah, there's the view function, and the view function composes the other 4 view functions. And my 2 pieces of the update function each compose 4 other update functions. This makes it harder to like add new components because I have to add them in multiple places, but I found that I just, like, probably the text input should be part of the landscape. My instincts are to break it down way smaller than it actually needs to be. Because of the typing and the immutability and the compile errors, Elm is just harder to get wrong. And I don't actually need to break it down and to decompose it as small as I would in a different language. Also, that model that gets passed through, that model is, I mean, it's global. Everybody's update function gets the entire model. I could change that. I could limit what I pass in, but that turns out to be a whole nother mess of boilerplate that gets really ugly, and it's just not worth it. Because I have immutability, so I'm not gonna futz with anybody else's data directly, and I have the compiler checking whether my change to my piece of the model messed anybody else up. It's just not that bad. And if I want, like, my text input likes to correct world to world, because I think that's funny. It's an inside joke from when my sister couldn't spell. And when it does that, it wants to send a message and have the messages pane display that, so I know how clever I was. And my instinct is, okay, well, I need the text input component to send a message over to this other component. Well, no, actually, I don't. Because that's really hard. That's a lot of wiring, trying to like publish some message that somebody else can respond. Just call the function. Just have the text inputs update function call through to something in the messages module, and let the messages module update its bit of the state, since it has the whole thing. It feels dirty to me, but it turns out it actually works quite well. And the compiler is making sure I don't screw it up. So that's different. Oh, but one thing you will not do while you're like creating dependencies here is make a circular dependency. We have time to see a circular dependency. So if I say open my model file and I add this statement to import main, which makes no sense, but it's definitely going to create a circle, and then I build landscape, I get this. This is even more beautiful than the other compiler error. Look at this. This is ASCII art in a compile error. That's fantastic. So yes, you cannot have cyclical dependencies between modules, which I appreciate very much. This is something I really liked about Clojure, although it frustrated me at first, but now it frustrates me about Java and Scala that nothing is stopping me from making a huge pile of spaghetti out of my packages. Elm will force you to keep your dependencies this way. You can have cyclical dependencies between functions in the same module so that you can do recursion. The namespace is global within one file, but that's it. The only circle you get in Elm is in Keynote. Is this circle, the event loop. Circles are really powerful. Okay, you've got like the water cycle and the life cycle, and circles are where things get interesting and powerful and complex, but they're also where things get really hard to predict. So I love that Elm has exactly one circle, and it's explicit, and it's predicted, and this is where you do interesting things in an event loop. Other circles are not okay. So I've come to have to release my hold on small components, on encapsulation. I used to really value libraries over frameworks, but I'm rethinking that. So I like libraries because they just get the work done. They don't tell you how to do your work, whereas frameworks tell you how to do your work. But then maybe there's a reason I never liked JavaScript. JavaScript is totally unstructured. You need a framework with it to give your code some sort of legibility, to make it possible to have some clue about where different pieces go and make decisions about that. JavaScript frameworks aren't just about making things magically work with less typing. They're about giving your code a shape that people can understand. Because if we want to change our code, and we always want to change our code, as soon as we write it, we need to change it. We wouldn't have a project otherwise. Then we need to have a model of the code in our heads. Code by itself is not nearly as powerful as code plus the model of it that exists in a person's head, because this is how we learn. Machine learning, super limited. AI, we're not even close, but if you add a person in the loop, in fact, in the opening keynote, he talked about balancing data with theory and logic with human cognition. And when you incorporate yourself into your program, that's when we get some really powerful ability to change. But in order to do that, I need to have a framework to hang the program on, and that's where the structure comes in. So whether it's MVC, technically, or Spring, maybe, pieces of it. In Scala, there's frameworks. We need to limit what we do to some sort of structure so that we can find our way around and pick up an unfamiliar code base or come back to a code base that's no longer loaded in our heads faster. So I'm favoring frameworks now. I'm saying if we have types and immutability really strongly and a solid structure like this event loop one, yeah, maybe I can let go of trying to make everything super tiny. I think there's a balance between what feels not just right, not just easy, but what feels optimal right now. Right now, I want it to feel natural to write the code. I want a DSL that makes it read really prettily, and I want some magic. I want the implicits to just make my monads come to me, and I don't have to say list.map to map a list and signal.map to map a map like you do in Elm. That feels natural, and it makes your code read more like English. But you know what? I don't want my code to read like English. I want it to read like code. I want it to read like Elm or Scala within whatever subset of Scala that I've decided to use. And I think that maybe what feels good to type right now and even feels pretty and elegant, we think we're building this castle, but we come back to it later and we're like, holy crap, how did I get over there again? As opposed to something that's structured and explicit, and that, it sort of scales over time better. And Elm is very balanced like that. It tries to make things not too hard for you right now, but also not too hard for you later. So now, I'm trying not to write polystructured programs. The other day I was writing a bash script, and I've been thinking about this idea of program structure from Elm, beyond things like design patterns, which are like pathetic little attempts at structure in a very small bits of your program. I was writing a bash script, and I was like, well, scripts have a structure. It's a very simple one. It goes down, it does one thing after another, or it goes out, and when it exits, and that's it. That's the only structure that makes sense in a script. And then I was writing my script, and I was like, oh, I need to do this thing twice. I should make a function. I stopped myself and I said, that does not fit in the script structure. A script goes down and then out. It doesn't go back and in. And so I was like, okay, well, what do I do? Oh, well, I just wrote another program. Because that's the unit of composition when you're writing a Unix script. I wrote another program that does that tiny bit, and then I call it twice from my script. And I haven't messed up the structure. It's just sort of little fractal. And I've been thinking about that a lot. Don't expect Elm to be Haskell. If you want Haskell, use PureScript. And I don't think Elm is ready for use everywhere. For instance, this, as of this morning, is my total gut feeling of the progress bars on these pieces of the Elm ecosystem. Compiler's great, package manager is pretty good, although the list of packages is still just one web page with an ever-expanding list of packages. It's not going to scale forever. The tooling is not there. Elm test, for instance, is a node. What do you call node things that you download with NPM? A node module. What do you call them? Turds. No, I don't call them turds. It's totally better than a turd. But I did have to manually change some things to get Elm test to work for me. It's not polished, that piece of the ecosystem. Build tools are just not a thing. My build script is 5 lines of bash. Editors, this progress bar sticks out farther because I think there's an incredible amount of potential here. You've got already the syntax highlighting in Sublime, Atom, Light Table, Vim, and Emacs. And maybe even a little bit of, I think I can find where that function is defined for you. I'm pretty editor neutral. I've used Vim for years and Emacs for years, and obviously I use Sublime sometimes. But I really am coming to appreciate IntelliJ more and more. I even use it for Ruby now. And Elm, as a strictly typed language, has incredible tooling potential. If you're using a strictly typed language and you don't have tooling built around it, you're losing half the potential of the typing, which is currently the case in Elm, because there's not a solid IntelliJ plugin, but I should be able to refactor. All this boilerplate should be just done for me, and it'll still be like explicit where I can click on it. But yeah, I think there's a ton of potential in editors for Elm, and we haven't hit it yet. Libraries are just not there yet. If you want to be super productive and get something out really quick, Elm is not going to be there because the libraries aren't all there, and you'll need to do JavaScript interop, and that's a bit of a work. I think we also, these bottom two are the most important because these bottom two are what's going to scale and increase everything else. I think we lack really good introductory materials. If you already have some functional programming, you're going to be fine. Just go through the Elm Architecture tutorial and it will make sense. But if you don't have that, or if you're like me and you don't actually know HTML, that's also a problem for me, but there's a lot of resources. I can go to Khan Academy, and I had to do that to actually learn. Actually, I learned some really cool stuff about HTML and CSS during this project. Did you know that there's HTML elements called main and aside and output, and there's other things like label's been around for a while, but I mean, I came from web pages in the day where we just organized everything in a big table with like TRs and TDs. That's where I learned HTML, so I'm like stretching to use divs and spans, but apparently divs and spans are like, so a couple years ago. And now you can use like semantically meaningful elements like main and aside, so my messages is an aside, and then I don't have to declare classes. I can just format my aside in ways that make sense. And this is like, it's declarative, and it's like, it's specific in its declarativeness, and I love that because then like the search engines can be like, oh, this is in an aside, so maybe it's not the most important content. I will go index the things in main. And that just, and it also, it makes me not hate writing HTML and CSS anymore, which is major progress. Yeah, so there's I don't think we're quite there with the learning resources yet, and Evan is not the person to build those because Evan knows way too much. I do think the community in Elm is great. There's lots of user groups. The mailing list is really nice. Yeah, and a lot of people here had already checked out Elm. I'm quite surprised by how much interest there is, given that it's not quite ready for production. Oh, one of the things that's missing from the compiler is dead code elimination. That's why those JavaScript files or the index.html is so big. Mine, for my little landscape app, is like 500K, which is not huge, but it's also not something you really want to deploy to mobile if you don't have to. So there's caveats. Mostly I don't want you to put stuff in production because I don't want people bitching at Evan when he makes changes. But do experiment with Elm. Learn how to think in event loops. You'll learn a lot about higher order functions because we use those a lot. And I also hope that it will raise your expectations for what a language system, for how a language system should treat you as a developer. Can we make it nicer? Overall, I think Elm has totally upgraded my front-end experience. This is Evan flying a kite. I'm Jessica Tron. You should totally go to elmlang.org and specifically go through the Elm Architecture tutorial. That is really well done and will really get you into this. And I didn't expect to have time for questions, but clearly I forgot some material. I know what one of it was. I didn't show you Elm CSS. That's another tool where you can like declare your CSS in Elm. This is another piece where Elm embraces generated code because you can use Elm to generate your CSS and put that in your HTML too while it's generating your JavaScript. And then you have type safe, like, did you get this class right? So you know if you change a CSS class, you can find where the different components that use it. But I have time for questions.
Thanks for the talk, really interesting. You mentioned that the graphics element library was deprecated, but I could see where that would actually be really useful in some situations, like building a game or something where you just wanted to draw things on the screen. So is it not supported at all, or is it just?
It's totally still supported.
Okay.
It's not like the direction, it's not the main direction of Elm now. But yeah, and you can totally use it for games.
Cool, thanks.
There's a question up here.
What does interop look like, and is there a conflict between JavaScript and Elm?
Okay, so the question is, what does interop look like? Is there a conflict between JavaScript and Elm? So Elm is totally designed to work with JavaScript. It needs to, and it works in JavaScript, and there's a lot of native implementations of things that are in JavaScript for performance. If I look in my main, so interop with Elm happens currently through ports, and you can define ports, I've got a couple here, at least one, in your main module. And this says, okay, there's a signal going out to JavaScript that is a list of JSON values. There's only a few things that you can send out, well, like strings, arrays, anything it knows how to JSONify, really, records. So the records encoded as JSON values. So I've got a signal of outgoing news that is my instructions to JavaScript, and I'm mapping it across, serialize it into JSON. And that gets sent to this out port, which in the JavaScript, I think I put that directly in index.html. Yes. So here is where I run the Elm app, and out of that I get this Elm app thing that has ports, one of which is called out, because that's what I called it. My JavaScript can subscribe to it and execute this function whenever it gets something. So currently, I'm sending out save requests, which is not implemented because I don't have a server yet, and focus requests. So if the data that comes out of my Elm says focus, then I do this focus thing, which is actually really annoying because the element doesn't exist yet, and so you have to put a timer around. Unfortunately, Evan had an example that I totally copied. And Elm format is not helping me with JavaScript. Right, and look at all these horrible null things. Oh. So that's on the outgoing side, and for things like HTTP requests and stuff, there's built-in libraries for that. Focus is not yet a built-in library. But you can also have an incoming port where in the JavaScript, I could say, like right here, if I wanted to, I could say, send to a different port this message, and it would come in as a signal in my Elm that would get to my update function and stuff like that. So the interop is totally there, and it's very, very explicit. Any more questions? Okay, well, thank you very much.